what's really important about the science stuff is this. This is the Ultimate Cell juice. Hi, I'm Peter Haddock, and now we're with Gary here, MD of Ultimate Cell. Ultimate Cell, it's like Ultimate Cell inside that I'm seeing here. You know, it's tiny, this thing, really.
It is really small, and we always reference it to the size of a can of beans, you know, and it is modular, so we can just stack them up depending on the size of the machine.
So in this context, we're putting one inside here. It's a test machine at the Lynch facility, but we've got an ability to put 3 in and even 6 in for some of their ADT fleet, isn't it?
Correct. As they get bigger with engine size and the fuel flow, we will just, you know, set them up as 3s or even 6s. So it's modular, and it just works for the size of equipment, giving it optimized performance.
So when I talk about all of these different things, I talk about data a lot. Part of the trial and now the rollout is looking at the data that's coming off the fleet as well, isn't it? And so tell me why that's important so people can actually understand the cost savings involved.
And I think that's the key to it, Peter. You know, people want to know what is the exact percentage. And the only way we can do that is by checking the telematics, working and collaborating with our partners, and then analyzing that to see how we can optimize the performance of the cell and the machine depending on the work it's doing. And then we can start improving on those figures to 1, save fuel, and 2, reduce carbon.
Yeah, so there's 2 different elements to that, like you said, the carbon and the fuel saving. But for me as well, what it allows us to do is it allows us to do something where the operator isn't really involved at all. It's just the maintenance team that needs to look at this. But how often is it?
Well, every 1,200 to 1,500 hours is when they would service it and top up the fluid inside.
Yep.
And from an operator perspective, they just need to check that the light is on green. There's no red lights. It's a very simple indicator, part of their normal daily and weekly checks.
Fantastic. So we've heard from James about how important this is to Lynch and the customers, but there's more to this conversation because this is what makes it go inside. This is what makes the whole system work. And I've got to tell you, we've had to set up a little lab here with Lynch and Ultimate Cell. So come on, let's go to the lab and discuss the real tech inside. Come on.
Come on, let's go.
So folks, we're now in the Lynch Ultimate Cell laboratory, Gareth, and this is the cool bit because we are talking about how this works. Right now, we've got power to this, and if you'll see, folks, there is bubbles coming out. Those bubbles, Gareth, are
actually hydrogen and oxygen. Yeah.
That's cool. So we've done a little setup here with the battery. So that's the energy coming from the machine. So just remind me again where we said we can connect into the cell to the machine and how it gets its power.
Exactly that, Peter. So it will connect to the asset via the 12 volt or 20 volt battery. Could be an alternator, or it could be into the fuse box as well. And that will power the device that's fitted to that equipment.
So what's really important about the science stuff is this. This is the Ultimate Cell juice, as it were, I call it. And this is potassium hydroxide, which is, I don't know what, so you're going to tell me.
Well, this quite simply, it's a high-grade potassium hydroxide. It's the electrolyte fluid that we use, and it is a high grade so that it can optimize the amount of hydrogen produced in the electrolysis process.
So before this, folks, we had a look inside one of these cells and we took off the membrane and looked at that fluid in there. So again, that needs to be topped up, but not very often, does it?
No, actually, it's every 1,200 to 1,500 hours, depending on how the equipment is operating. And on a vehicle, it's between 12 and 15,000 miles. So depending on the piece of equipment, it actually normally ties in with the second or even first service cycle.
So that's really important, folks. And we've now got 85. In fact, I've probably got the 86th getting fitted outside of these units here. But we talk about the singular one. But at the back here, we've got a bank of 3. Why would we have the bank of 3?
Good question. Typically one unit, they are modular. So that will service up to about a 3 litre as a general rule of thumb.
Yep.
And if it's anything bigger than that, which Lynch have a lot of equipment, you know, that size plus,
yep,
we go to the triple cells. And in the very, very big parts, we will probably need 6 cells, or we double up on the triples depending on the space.
Yep.
But it is relevant to the fuel flow and engine capacity.
And so the really big ones is this is on the excavator, but it's also going to be on ADTs as well, 35 to 40 ton ADTs.
Correct.
That's a big machine using a lot of fuel, isn't it?
It is. And those typically will burn anything from, say, 24 up to 30 liters per hour. So when you start to get a 5, 10, 15, 20% saving, it all starts to add up.
Absolutely. That's a huge amount. So science hat on yet again, folks, because this is really important for me. This fluid in there allows us to put electric current into there that then does what?
So it's good question. It splits the fluid into hydrogen and oxygen.
Okay.
So H2O normally, and it gets split into H2 and O. So that is what we then feed into the air intake, which aids as a catalyst in the combustion process.
So lots of people, when we talk about burning hydrogen, talk about the water that comes out of the end.
Correct.
It's not the case, is it, here? This is about the mix, isn't it? So tell me about how that mix works and how this gets into the actual process with the diesel.
Correct. So what this can do is pretty much produce up to 1.5 liters of hydrogen per hour.
Right.
When you add that into the mix of the fuel blends, it's typically between 5 and 15% roughly. And that then goes in as a molecule gas, which fracks the fuel, and it aids as a catalyst, aiding the fuel burn process. So typically where you lose a lot of energy through heat and other sources in an engine, what we're doing is just refining that and making sure it's optimized to get a more complete burn.
Now, my science tells me something that's really cool that you mentioned earlier, so it wasn't me, that actually hydrogen cools the engine.
It does. It's actually known as a cleaning and cooling agent. And because it's burning a lot quicker, it burns at about 10 times more than your normal fuel.
Yep.
So you get that initial heat and that power, which increases the torque. But actually, as it dissipates through the rest of the engine, you don't have that burn carrying on throughout the process, which happens in some instances. So it's a complete burn, a lovely blue flame, if you would imagine, that goes through the system cleanly without carbon. The opposite would be an orange flame with the kind of soot and smoke. Yeah. Exactly. So we don't have that using this process.
And what that means is the engine's cooler. So therefore, you know, when we talk about getting really power modes, engines getting really, really hot, then, you know, that impacts the wear of some of the components on an engine over time as well, doesn't it?
It typically would, but in this instance, it impacts positively.
Right.
So what you'd have is a much more complete burn, and you've got the mechanical and chemical benefits. So the efficiency is optimized in those two fashions, and it just means that you start to get a better running engine, higher torque, and as a byproduct, which is a good byproduct, saving fuel.
Well, that saving fuel is huge, and I think that's what we'll come on to that. But the other thing is down the line, we've had filters that come and filter out the particulates that you're talking about with the different burns and things like that, yes, when an engine is optimized or not, as the case may be, with the utilization. And so when we do that, the filters take out a lot of those particulates.
Correct.
But when you mentioned to me earlier, that process of burn reduces the amount of the particulates.
Exactly. And the good news is this is happening at the front end in the combustion process. Most of those features are fitted on at the end process, exhaust onwards. Yep. So you can see there that they're dealing with the particulates and reducing the gases, which is great. But if we can control and reduce those inside the engine in the combustion side, yep, it means less soot, less emissions, and much more efficient operation.
And just remind me, so it comes in at the air intake and then the turbo sucks it in, you mentioned.
Correct. So what we would do is once you've got your power supply, you can see here that we've just got 2 pipes. This one is for the vacuum, which will work on demand and works out the pressure of the engine and how much it needs to then pump in terms of the hydrogen. Yep. And the top one is the feed. So we would simply put that pipe into the air intake just before the turbo and after the MAF sensor. So it doesn't interfere with anything. The turbo then sucks the hydrogen into the combustion process, allowing that complete burn.
So we've got all the chemistry bits, all the lab bits are done, folks, but let's just think about the fuel saving. So we've got the carbon saving, we've got actually a saving on maintenance and everything like we talked about, and fuel filters and things like that.
Correct.
What is the actual saving for people?
Well, it does vary depending on the workload and,
course,
the fuel sizes, but typically we've seen through testing anything from 5 to 15% after with heavy loads.
Yep.
And typically when you've got your optimum running level, you can get up to 40%. So as a company, we guarantee a minimum of 5%, but we have seen some people, depending on the operations, at the upper levels.
Right. So that's really interesting. You've got the stats to back that up, because this is not new, is it? This has been used elsewhere. There's like 85, 86 units now that Lynch that are fitting around the fleet, but it's been used elsewhere in the world and proven, hasn't it?
It has. I mean, we're actually in 65 countries plus. It's in over 38,000 units, and it's been doing really well. And this goes back to 12 years ago.
Right, okay.
Actually, when you look into the processes of hydrogen, we've got it patented, and it's a brilliant product, but this does date back to previous times. So hydrogen has always been there, but it seems to be coming to the forefront now, and it's certainly something to make people a little bit more comfortable with, and this is a great transition.